heart of your backyard food production system is in the garden. Let's start with where you want to put your garden if you have a choice. We tried 4 different places and learned a lot from each location. Many gardening books are written for gardeners in the northeastern part of the U.S., and that wisdom says to plant on the south-facing slope. So we put our first garden on this south-facing pasture. We laid out at least 4 or 5 layers of cardboard to cover the Bermuda grass, and then we piled up an 18-inch thick mat of hay on top of the cardboard. We punched holes through the cardboard and planted down in that. Here in Texas and most of the Southwest, we have an intensity of sun. With the continual wind and heat on that south-facing slope, we could never keep anything moist enough to grow. We also found that Bermuda grass has no problem finding its way through that much cardboard and mulch. Our next 2 garden sites were in the orchard area on the northeast slope, which was better in terms of the coolness and moisture. And the main lessons that we learned again were that Bermuda grass is a formidable challenge, and even a short walk of 150 to 250 feet was too far away. The garden has to be right by the house if it's going to be tended well. It's why they're often called kitchen gardens. Another consideration in locating your garden is the effects of shade or trees or structures surrounding your garden. These shadow maps drawn during the summer solstice are an easy and helpful tool you can use to get a sense of how much light an area gets. Getting morning sun and afternoon shade is an ideal combination for Southwest gardens. How much garden area do you need? Fortunately, a man named John Jevons has been working on this question since the 1970s. He's developed a complete method of sustainably growing food called biointensive gardening. We keep coming back to this method as it's designed to provide a complete diet taking into consideration proteins, fats, carbohydrates, minerals, and vitamins that you need. The method is used throughout the world, and it assumes that you start out with little soil or money. From the biointensive research, to sustainably grow the entire food needs of one person requires 4,000 square feet of growing space. This drawing shows 40 100 square foot beds. You can fit these 40 growing beds into a 7,500 square foot area if the paths are mostly about 1 foot wide. This is the space needed for a complete vegetarian diet for one person. Now, of those 4,000 square foot of growing beds, 2,800 square feet are primarily for growing compost materials to replenish fertility in the system, and only 1,200 square feet is for active food production. The biointensive method focuses on a vegetarian diet in many places in the world where his methods are used that people can't afford any livestock. In our garden we have a small rabbitry. The rabbits provide meat and, almost more importantly, fertilizer. Our setup here with 750 square feet of bed space and the 8-cage rabbit hutch is enough to feed one person fairly well year-round. Now, this is not a complete system as it depends on bringing in cut greens and grasses for the rabbits and hay for both the rabbits and for mulch. Once it is established and you have the experience to manage it, it takes about 10 to 15 hours per week to grow all the food you need in a setup like this. Our inspiration for the garden rabbit synergy comes from a missionary group outside of Waco, Texas called World Hunger Relief. World Hunger Relief has a manual titled Backyard Food Production, which we highly recommend. They also offer courses and workshops. After trying the other locations, each with really big areas, we started this garden with just 1 bed and then added more space slowly each season. And we highly recommend that you start small. Jevons thoroughly describes the biointensive gardening method in the book, How to Grow More Vegetables Than You Ever Thought Possible in Less Space Than You Ever Imagined. An easier introduction to the method is contained in the book, The Sustainable Vegetable Garden, also written by Jevons. We can't teach you the whole method on this video, but here are some key points. In a new garden, measure and stake out a bed. Many of the beds in this garden are 4 feet by 12.5 feet for a total of 50 square foot per bed. This is actually an established bed, and we will explain why we have these trees in the middle of the row later in the section. For a new bed, if you can get a soil test done, that will help you determine what minerals can be added to enhance fertility. Adding soil amendments is only done once in the beginning of establishing a bed. ATTRA, A-T-T-R-A, the Alternative Technology Transfer for Rural Areas, has many free online resources for sustainable farming. They have given us permission to include in the documents section a paper discussing mineral content in a variety of homemade and commercial soil amendments. But before soil tests came along, people knew the soil quality by looking at the weeds that grew in it. And one source for that kind of information is a book called Test Your Soil with Plants by John Beebe. Different layers of soil have different levels of biological activity, and the biointensive method takes care not to overly disturb soil layers. If you have a clay-based soil, the soil is prepared by a technique called double digging. Here we have mostly sandy soil, and double digging is not necessary. If you have rocky soil, well, you're going to need to import your soil and have raised beds. In fact, if you can afford to buy good soil right at the start, just do that. If not, don't worry, you can grow your own over time. Growing soil is one of the foundations of the biointensive method. We mark the corners of the beds using this rebar and PVC pipe. The PVC can rotate easily when the hose is dragged around. Once the bed is laid out, you never step in the bed, but always stay on the paths. Stepping on the bed causes soil compression and damage to the roots. We use a kneeling board to distribute weight if we have to get onto the bed. Another key of the biointensive method is to conserve soil, space, and time. Seedlings are started in flats and then transplanted into the garden when they are large. Garden beds are only used by bigger plants. These are corn seedlings. Corn is not the best food crop in terms of calories and nutrition. We grow it because the kids love it and it gets them involved in the garden. Growing so intensively means you need to replenish the fertility on a regular basis. Before each new planting, we add a specific amount of compost. In this case, 3 to 6 5-gallon buckets of compost to a 50-square-foot bed. Corn is a heavy feeder and needs a lot of fertility to produce well. Other plants like squash and turnips don't require much fertility, and the legumes like peas and beans add fertility to the soil. In the biointensive method, crops are planted in a hexagonal pattern at very specific distances, which maximize yield while minimizing the amount of soil needed. In a hexagonal pattern, you can fit in a lot more plants than conventional straight rows. There's much more to the biointensive research and the biointensive method. If you can't find a gardening teacher, don't worry. Take any gardening classes you can and hang out with neighbors who garden. Get the biointensive book and integrate as much as you can. The secret to a green thumb is mostly fertility. The majority of common vegetable garden plants need to have good, rich soil to produce well, and we struggled for several years with many losses before learning this fundamental lesson. Regardless of your soil type, continually adding compost is the main key to fertility. Clay soils, sandy soils, rocky soils, compost fixes them all. So how do you make compost? Basically, you need lots of organic matter. If you recall, in the biointensive method, with the 40 growing beds, 28 of those beds are for growing organic matter just to make compost. Fertility is that important and that challenging. The plants in those 28 beds are sometimes called carbon crops. Making compost is easy. We've included several documents describing various composting methods in the documents section. Here's a brief overview, though. For the purposes of compost, all organic matter is divided into roughly 2 categories, browns and greens. Some examples of browns are dried plants, hay, newspaper, cardboard, and leaves. Some examples of greens are green plants, fresh grass, vegetable scraps, and manures. To make compost, you make a pile with a 50-50 mixture of greens and browns, you add water, and you let it sit. Turning the compost every few weeks will speed up the process. In a little while, nature will work a miracle, and you will have this rich black stuff that is so good for your plants. We have numerous compost piles. Our most high-quality compost is our worm bin. Worm castings make an excellent fertilizer. We use this compost for brewing compost teas and for inoculating special areas. Brewing compost tea and manure teas are also an excellent method to help increase fertility. Teas can be brewed at home with just these simple supplies. We have directions to get you started in the documents section. Our second best compost pile is under the rabbit hutches. Note that these piles are protected by the garden fencing because chickens and dogs can easily mess up a compost pile, so the fencing is important. Now, chickens put out a lot of manure when they're roosting at night, and here is a very simple compost pile under this roost. So even though the birds are completely free range, we can still utilize their waste by simply developing a compost pile underneath where they choose to roost. Unfortunately, this happens to be on the top of our little shed. Note that the manure from pure herbivores like rabbits, cattle, or horses can be put directly on the garden. But manures from chickens and turkeys are too hot and need to be composted first. Actually, all manures will do better if they're composted with other things for a while, but we know how you can't wait sometimes. This is the classic way to do compost piles, using pallets to help generally keep the material confined, and yet it also lets airflow into the pile. Unfortunately, during drought conditions, we don't have enough organic matter to fully utilize this area. Also, don't forget your own waste as a source of fertility. Human urine is approximately 18% nitrogen in a highly plant-available form. The nitrogen content varies depending on your protein intake. To use urine, dilute it 10 to 1 and apply to leaves or root areas. We know several people who use primarily urine to feed their vibrant gardens. Carol Steinfeld has written a book called Liquid Gold. According to Carol, your urine has enough nitrogen to fertilize half to all of the plants needed to sustain you. The Humanure Handbook is the classic reference for composting human manure. Human feces can safely be composted and used in the garden or orchard. It takes about a year to fully compost out the pathogens, and yet there are a lot of other places in the world where they don't wait that long. Tom Watson developed the Watson Wick, which is a type of septic system designed to be able to safely use human waste to directly fertilize fruit and nut trees. If you need to redo your septic, or if you need to build a new one, this is an option to consider. We do another form of composting, which is very crude, in our garden with our footpaths that also helps with grass suppression. We line the paths with whatever organic matter we can find: old junk mail, newspapers, old cotton or wool clothes, phone books, whatever. We cover it with hay and then water it in. Most inks are soy-based, and most glossy paper is clay-based. And if a little bit of plastic gets in there, well, it'll decompose eventually too. How much water your garden needs will vary by many factors. For example, on hot, clear days with high winds and sandy soil, you're going to need lots of water on a daily basis. On cool, overcast, still days in clay soil, well, you won't need to water at all, probably for several days to a week. You'll also find that different parts of your garden have different needs. And even within a bed, there are variations. For example, the corners tend to be drier than other areas. There's an old gardener saying, "Water the edges and the center will take care of itself." A key concept to keep in mind is that you're watering the soil, not necessarily the plants. A classic way to tell if you've watered enough is if the surface of the soil is shiny for 5 seconds. Since we use a lot of mulch to help conserve water and can't really use the shiny method, we feel the soil around the base of the plants about 2 inches deep to get a sense of the moisture level. We found that fully automating the watering system had us lose touch with the plants. So currently we water mostly by hand. And occasionally we water with a small sprinkler on a timer that we move around. We usually water in the early evening before sundown. If it's really hot, we water in the middle of the day to help cool off those struggling plants. Now the exception to that is sweet potatoes, which need some stressing to grow their tubers. Wind causes stress to plants and dries out your soil, and that's why we have this windbreak all around the garden. On the outside of the fence, we are planting perennial evergreen bushes, which will become a natural windbreak, as this material is only a temporary solution. Of course, the windbreak bushes we plant will be something useful or edible or medicinal. Getting the right amount of sunlight to your plants can be very challenging. Using the shadow maps we mentioned earlier is an easy way to check out just how much sun each part of your garden is getting. In most locations in the Southwest, in the summertime, a lot of plants do better with some shading from the intensity of sun. In our garden, we use these small, fast-growing trees down the middle of the rows to provide shade in the hottest months. The 2 trees we like to use the most are Lucena and Moringa. Both of these trees are native to tropic climates and die back with the first freeze, which is typically mid-November here in central Texas. This is good, as we don't want shading during the winter months. We are filming in early June, and the Lucena is already up and going. This plant grows rapidly. It will soon be providing the shade we need. Here's what the Lucena looked like in August of last year. This row was planted specifically as feed for rabbits, and we have realized that this close of a spacing, about 1 foot, is too dense a shade to grow anything underneath it. Planting the trees 3 to 4 feet apart makes a better level of shading and sunlight for the vegetable crops underneath. These rows are oriented north-south, which allows sunlight during morning and afternoon hours, but gives a light shade during midday. Both the Leucaena and Moringa are heat and drought tolerant with many other uses. Leucaena is in the legume family and fixes nitrogen in the soil with its root system. This helps to fertilize the other plants grown around it. Also, Leucaena's young pods, leaves, and seeds are edible. The dead trunks left behind in winter can be left in place to make an easy structure to drape with protective coverings, or used as a scaffolding for vining plants. All parts of the moringa tree are edible and or medicinal. The leaves of the moringa are highly nutritious for humans and livestock alike. The moringa seeds can be used to purify water. In addition, these trees with their transpiration of water helps create a lush microclimate in the garden, cooling the area and reducing your water usage. There is just a tremendous amount of research available on both these trees, as they are used extensively in developing countries to alleviate hunger and malnutrition. See the document titled Plant Allies for Southwest Gardens, along with other information in the documents section. Also, we will have more to say about Leucaena in the Perennials and Other Essentials section of this DVD. Most insects are beneficial to the garden. Malcolm Beck has written the classic book, Texas Bugs, the Good, the Bad, and the Ugly, which has some wonderful insights into the many dynamics of insects in the garden. In his book, Malcolm explains that nature primarily sends in insects to attack only weak or unhealthy plants. So the main answer to all bad bug problems is to make sure you have healthy plants. We have a two-step process for dealing with serious insect outbreaks. First, we let the chickens or guineas into the garden for a short time. The poultry have a preference for insects and they eat them first. We watch them, and when the chickens have finished the bugs and start eating the greens or scratching up the beds, well, then we run them out. The second step is we immediately address the underlying issue of weak or unhealthy plants by adding some fertility, checking the watering, weeding, mulching, or whatever is necessary. Some other more preventative techniques we use to minimize bug problems is we rotate our crops using different locations each year. This helps to disrupt insect reproductive stages. We use this graphical snapshot every few months to keep track of what was planted where. And although this is not a complete record-keeping system for the garden, it is quick and easy, and actually sometimes it's all we can do. Another technique is to always have a few things flowering in the garden, as that helps to keep the good bugs in the area. The good bugs often eat the bad bugs. Sometimes those flowering plants are just simply weeds, sometimes they're old crops on the way to seeds, and sometimes they're intentionally planted. Another option for bug problems that we are learning about is to eat insects. Some of them are downright yummy, and it sure turns an insect problem into an opportunity. We used to get very hung up trying to find the absolute best variety of vegetable plants. While having a good variety that is heat or drought tolerant does help, having good soil, adequate moisture, and the right amount of sunlight is by far going to get you more success. Your local garden club or gardening neighbor is the best source of varieties to use. Buying seeds in bulk and sharing with neighbors is a very cost-effective way to get seeds. To store seeds, the key thing to understand is that seeds lose their viability with exposure to moisture, light, and heat. Ideally, seeds should be stored in around 5% humidity in the dark below 50 degrees Fahrenheit. If you have a refrigerator available, store seeds in a tightly closed jar in the fridge. The cupboard above the stove is not good. Saving seeds from your own plants is ultimately the way to go. You can get crops that are highly productive and specifically suited to your soil and climate. We have included in the documents section an excellent beginning book on seed saving written by Bill McDorman. Start out with some of the easier seeds to save, such as beans, tomatoes, or okra. These do not need to be isolated, and the seeds are large and easy to handle. It really does take about a decade to become skilled in growing your own food. Getting started can sometimes be the hardest part, but here are some suggestions to get you going. First of all, get a compost pile going. Then start with one garden bed. Only add another bed every other season as your experience and skills grow. Initially, buy some starts from the garden center and wait to try starting from seed until later. Take all of the gardening classes that you can and visit as many gardens and farms as you get the chance. Get the Biointensive Gardening book by Jevons and start incorporating as much of his methodology into your efforts as possible. Don't worry yourself with seed saving or companion planting, moringa or leucaena or moon phases until later. We know there are pressures to get as much going as soon as possible, but starting small will really be the best use of your resources. Be prepared for failures and just keep on replanting. If nothing else, life will surprise you.